Agriculture plays a major role in our day-to-day lives. It affects everything from what's on our plate to what we wear. For example, the cereal and milk that I ate this morning are agricultural products. The sheets in my bed, the pajamas that I'm wearing right now, and yes, even the Q-tips for my ears are made from cotton, again, an agricultural product. Now, almost all of these everyday necessities were produced via intensive agriculture. So, what makes intensive agriculture different, say, from backyard gardening or traditional agriculture? Well, first, intensive agriculture is done at a very large scale, meaning that agricultural operations take place over hundreds to thousands of acres. Think of the never ending corn and soybean fields in the Midwest. Secondly, it's highly mechanized, and large machinery like combines are used to increase the speed and efficiency of activities like sowing seeds or harvesting crops. And as we'll focus on today, intensive agriculture relies on a huge amount of landscape modification to increase crop yields, namely via tilling, slash and burn farming, and fertilizers. These agricultural practices, though, can have really detrimental environmental impacts, as we'll explore. First, we'll start with tilling. Tilling is the process of turning soil to control weeds and other pests and to prepare the soil for seeding. By digging, stirring, or overturning, compacted soil can be broken down into finer pieces and allow for easier planting of crops. Although tillage has been done for thousands of years, this practice has evolved from using human labor and draft animals to till small fields on an annual basis to heavy mechanized equipment that can till thousands of acres multiple times per year. Now, soil tillage can help to loosen and aerate soil, but repeated and intensive tilling can loosen soil to the extent that it starts to lose some of its structural integrity. In other words, as soil is broken down into smaller and smaller pieces, called soil aggregates, its ability to store water and nutrients is reduced, which can result in surface runoff and soil erosion. On top of that, tillage also reduces any leftover crop residue, like plant stalks. So, in turn, the exposed soil surface becomes highly vulnerable to wind and rain because nothing is really holding the soil down or providing cover. Collectively, wind, rain, and the lack of plant cover can work together to accelerate soil loss through erosion. In particular, the loss of the topsoil, which contains the highest concentration of organic matter and microorganisms, can lead to water pollution as well as a loss in soil fertility, as organic matter and nutrients are literally washed or blown away. However, low-till or no-till farming alternatives can mitigate some of these problems. In the Palouse, a major agricultural area in the western United States, no-till farming is especially important because fields are, well, they're very steep and hilly, and wind and rain can cause a lot of erosion when the soil is heavily tilled. By not tilling the fields, farmers can help to increase organic matter content in the soil and prevent soil erosion. Beyond tilling, slash and burn farming is also used as a common agricultural practice. This method first involves clearing trees and woody plants from forests or woodland areas, especially in tropical climates. The down vegetation, or slash, is left to dry and then burned. In the process, the slashed area is temporarily cleared of weeds and other undesirable plants. Burning produces a nutrient rich, but again, temporary, layer of ash in the soil, which increases soil fertility. However, the effectiveness of this agricultural practice is pretty short-lived. After about 3 to 5 years, the productivity of slashed and burned plots decreases rapidly due to loss of nutrients along with weed and pest invasion. In turn, farmers abandon the field, move over to a new area, and repeat the process. But it really is more of a vicious cycle. For example, slash and burn farming is commonly used throughout the Amazon. As acres upon acres are burned, enormous amounts of greenhouse gases are released. In tropical ecosystems, the great majority of carbon is retained in trees and other vegetation. As they're burned, carbon is released as carbon dioxide and contributes to global climate change. Sometimes fires may not be well managed and can burn out of control, causing enormous, costly wildfires. Air pollution via smoke from fires can be very hazardous too. And even after areas have been burned, farmed, and then abandoned, it can take decades for these plots to recover. There are, however, alternatives to slash and burn, which includes pairing farming with animal husbandry and using waste from the animals as fertilizer to sustain agriculture, or using alley cropping. Speaking of fertilizers, that brings us to our next topic. For thousands of years, farmers have relied on natural fertilizers to replenish or increase nutrients in the soil and promote plant growth. Natural fertilizers can come from a variety of sources, including crop residue, manure, wood ash, ground bones, fish or fish parts, and even bird and bat waste called guano. In the early 1800s, scientists discovered that nitrogen, phosphorus, and potassium were most essential to plant growth. In time, many farmers began to switch from natural fertilizers to artificial fertilizers with higher concentrations of these elements. Now, many farmers use chemical fertilizers with nitrates and phosphates because they greatly increase crop yields. However, fertilizers can come with another set of problems. Excess application of fertilizer can cause runoff into local surface waters and cause pollution. As nutrient rich materials like fertilizer make their way into nearby rivers, lakes, and oceans, they can cause major problems in the balance of nutrients in marine ecosystems. When a body of water receives too many nutrients, the water becomes eutrophic, in other words, highly rich in nutrients. In turn, these nutrients feed the growth of cyanobacteria or algae, which rapidly consume dissolved oxygen and create anoxic or oxygen poor environments. These algae can also form a thick layer near the top of the water and block sunlight and oxygen from entering the body of water. These massive algae blooms can result in enormous fish die offs or dead zones where few other organisms can survive due to the low oxygen conditions. To reduce the amount of nutrients released into waterways, farmers can limit the amount of fertilizer that they apply or recycle water for irrigation. Farmers can also use compost, which is decomposed organic materials, as a fertilizer, which tends to have lower levels of nitrates and phosphates.